right, now we're going to continue with our focus of volume, but this time we're going to look specifically at finding the volumes of cones. If we were actually together in the classroom, I would probably have us do a hands-on activity to discover the formula, but since we literally have no time left, I'm going to go ahead and just give you the formula. So it can actually be written two different ways. The first way is 1/3 times B, and notice again it's a capital B, times H. It can also be written, because remember that multiplying by 1/3 is the same thing as dividing by 1/3. So you could also write it as V equals capital B times H divided by 3. So let's go ahead and define the variables again to make sure we know what each of them stands for. So once again, the capital B is the area of the base. That's why it's capitalized. So if you look at a cone, once again, we have a base that's a circle. So we're going to use the same formula that we did in the last one with the cylinders, and that to find the area of a circle, which is pi r squared. And then the H, this time it stands for the height of the cone instead of the height of the cylinder. So we're going to do some examples together. We'll do a couple in which we're going to find the volume, and then we'll do some where we also have to find the height. So this first one, we're trying to find the volume. I didn't give the directions. I should have done that. But yes, you're trying to find the volume. And once again, notice that you're given the diameter. And if the diameter is 4, you know that the radius is half that amount. So the radius is 2 meters. And then the 6 is the height of the cone. So I'm going to go ahead and plug in those numbers to the formula. This time I'm going to use the 1/3, but you can use the multiplying by 1/3 or dividing by 3 interchangeably. It does not matter. So capital B stands for area of base. So that's pi r squared. So that's pi times radius squared, which is 2 squared. And then times the height of the cone. In this case, it's a 6. So now I'm going to start simplifying or evaluating that expression. We know exponents come first. 2 to the second power is 4. So I've got 1/3 times pi times 4 times 6. Now I can go ahead and multiply all the numbers together. And remember, with multiplication, it's commutative, which means you can multiply in any order that you want. So let's start with 4 times 6, which is 24. And then let's multiply 24 times 1/3. 24 times 1/3 is the same thing as 24 divided by 3, which is 8. And then, of course, we have that pi symbol. So the exact volume of that cone is 8 pi cubic meters. Remember, as we did with cylinders, if you're leaving it as an exact answer, you leave the pi symbol in the answer. To get the approximate volume of that cone, let's go ahead and plug in 3.14 for pi. So I'm going to multiply 8 times 3.14, and I get approximately 25.12, but usually we round to the nearest tenth. So the approximate volume of this particular cone, rounded to the nearest tenth, would be 25.1 cubic meters. So here's our exact answer. Here is our approximate answer. This next example that we're going to do together, we're already given the volume and we're trying to find the height. You'll see right here that the H, we don't know what H is. That's our goal. So I'm going to go ahead and rewrite the formula. Volume equals 1/3 capital B H. And that capital B again stands for the area of the base, which is a circle. And notice this cone is on its side. So I'm going to plug in this number for volume, 956, is equal to 1/3 times the area of the base is pi r squared. Our radius is 9, so pi times 9 squared times the height, and we don't know height. Since we're trying to solve for height, we're going to go ahead and just get an approximate answer. So rather than trying to leave it in terms of pi, which I think will make it very confusing for some of you, I'm going to go ahead and plug in the 3.14. So 956 equals 1/3 times 3.14 times 9 to the second power, which is 81, times h. I'm going to go ahead now and multiply all of those numbers together on the right side of the equal sign. So 1/3 times, or excuse me, let me do the 3.14 times the 81 first, and then do divided by 3. When I multiply those and I divide by 3, I get 254.34. So 956 equals 254.34 times h. Last thing I need to do is use inverse operations to isolate the h. So in order to do that, I'm going to multiply both, excuse me, I'm going to divide, not multiply because that's the inverse, both sides of the equation by 254.34. So 956 divided by 254.34, I get h is approximately 11.276, but I'm going to go ahead and round it to the nearest tenth and say that the approximate height of this cone is 11.3 feet. All right, so a couple more examples together. On number 3, which is the one that has the 1 here, we're finding volume, and then on number 2, we are finding the height. So let's start with the blue one. So we know the formula is volume equals 1/3 times B, which is area of base, times H, which is height of cylinder. So area of base is pi r squared. So that's, radius is 6, so 6 to the second power, times the height of the cone, which is 15. So let's do the exponent first. 6 squared, which is 36, times 15. Now I'm going to go ahead and do 36 times 15, which is 540. And I'm going to go ahead and move it over here. It doesn't really matter what order you write the numbers when you're multiplying, because it doesn't matter what order you multiply. All right, now I'm going to, if you're using a calculator and you're not sure how to type in 1/3, first of all, don't ever round with your calculator. Put the 1/3 in parentheses, or in this case, make it really easy on yourself and just do 540 divided by 3. So 540 divided by 3 is 180. So the exact volume would be 180 pi cubic centimeters. The approximate, remember, I'm going to go ahead and multiply the 180 times the 3.14. So the approximate volume would be 565.2 cubic centimeters. With this example, I have the volume and I'm trying to find the height. So I'm going to use the same formula, but I'm going to plug in this number, 7,200, for V, which is volume, is equal to 1/3 times pi r squared. Radius is 15, so that's times 15 squared times h. We don't know h, so we're going to leave it as h, and that's what we're solving for. 15 squared is 225. Times, I'm going to go ahead and plug in the 3.14 here. I'm running out of space. Okay. So now I'm going to multiply all three numbers that I have here. I'm going to multiply the 1/3 times the 3.14 times the 225. Or I could do 3.14 times 225 and then divide that by 3. Regardless, I should get 235.5. And my last step in isolating that h is to use the inverse operation of multiplication, which is division. So I'm going to divide both sides by 235.5. Cancels out on the right side, and I get an approximate height of that cone to be 30.6 yards. This last example, we actually have to do a little bit more work. So you'll see we have two glasses, glass A and glass B. The inside of each glass is shaped like a cone. We're trying to figure out which glass can hold more liquid and how much more. So in other words, we basically need to find the volume of both of the glasses, the cone part of the glasses. So let's go ahead and start with glass A. We're going to find the volume. We know that it's 1/3 times pi r squared, because that's the area of the base. So pi times 4 squared times the height of the cone, which is 8. 4 squared is 16. And now I'm going to go ahead and multiply the 16 and the 8, which is 128. And since we're trying to figure out which one holds more, let's go ahead and just leave this one, leave the volumes as approximate and not worry about leaving it as an exact answer. So I'm going to go ahead and plug in 3.14 for pi. So first I'm going to do 128 divided by 3, which is 42.7. And now I'm going to plug in 3.14 for pi. So that means the approximate volume of glass A, I'm going to use that approximation symbol, is 134.1 cubic centimeters. Now I need to find the volume of glass B, which is also a cone inside. So glass B has a radius of 3, so that's pi r squared, that's pi times 3 squared, times the height of 10. So let's go ahead and simplify that exponent. 1/3 times pi times 9, because 3 squared is 9, times 10. 9 times 10 is 90, and 90, well, I'll go ahead and write that step just so you can see what I'm doing. 90 times 1/3 is the same thing as 90 divided by 3, which is 30. So I end with 30 pi. And I need to go ahead and get an approximate answer. 30 times 3.14 is, so this is the approximate volume of glass B, 94.2 cubic centimeters. So we can already tell by looking that glass A is going to hold more liquid. But we're not finished because we didn't answer the question. We need to actually write out which glass can hold more liquid, and then we need to answer the question, how much more? So I'm going to go ahead and say glass A holds more. And the way that I'm going to figure out how much more is I'm going to subtract the volume of glass A minus the volume of glass B. So 134.1 minus 94.2 is glass A holds approximately 39.9 cubic centimeters more of water. I know that was a lot of steps, so feel free to rewind or pause and take your time. and email me or join me for office hours if you have questions. Good luck.